Hello viewers, welcome back to my channel. I hope you are enjoying all the videos that I am uploading. If you haven't subscribed yet, please subscribe to my channel and also share among your friends. So today's problem is verifying an alien dictionary. In alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of alphabet, return true if and only if the given words are sorted lexicographically in this alien language. So basically, excuse me, we have an alien language and they also use lowercase alphabet, that is 26 lowercase alphabet in English, A to Z, but the order is a little different. So based on that order, we have to validate a set of words whether they are ordered lexicographically or not. So lexicographically means it's a dictionary order basically. So if you look in any of the printed dictionaries, right? So that is what the lexicographical ordering is. So let's go ahead and look at the example 1. So words that were given with are hello and Leetcode, right? So normally hello comes first in the dictionary and Leetcode comes next, right? So if you go look at, right, H is the first and then only comes hell, right? HIJKL. So in the normal dictionary, hello comes first and Leetcode comes next, right? But the order given here is a little different. That's what it said, right? So H comes first, A next, and then A, B, C, D, E, F, G, I, J, K, M, N, O, and so on till Z. So H and L are not in their original position as that of in English alphabet, right? But even in this case, H is coming before L. So the order of this is actually still true, even though they changed H and L places from the original English alphabet to H comes first, L next, and then starts with A, B, C, right? So even then H is coming before L. So here also the word which is starting with H is coming before Leetcode, right? So we could say this is a good sorted. That means they are in a lexicographical ordering. So there is not much complexity in this example. Let's go ahead and look some more examples to understand more about the problem, right? So yeah, so example 2 is very good example basically. So word row, right? So in this case, word A, B, C, E, F, G, H, I, K, M, N, and so on, right? So basically here word, world, and row. So when you compare the first letters, right, W, here also W, and here it is row. So when you compare the first letter, they are in order because first comes W and then comes R, right? So they are in order. But since there is a match of more than one letter, if there is no match, you could, if there are only two words, word and row, right? So then if word comes first and row next, then that is good. But here in this case, word and world both are there, right? So in that case, which one should come first, right? That is what we have to actually go ahead and look at it. So when you compare single letter, both of them match. Compare the next letter. So we have to keep on comparing until there is a letter which doesn't match or one of them becomes empty. Excuse me. So in this case, WOR, so it matches the first three letters. So there we cannot sort based on that, right? So that the third character or the fourth character, you could say 0, 1, 2, 3. The fourth character is D here and the fourth character is L here. So we have to compare which comes first, whether D comes first or L comes first. So in our alien dictionary, L is coming first and then comes D, right? So that means the order should be reversed. world should come first and then only word should come, right? Because L is coming first and then D, right? So that means this should go into the first place and word should come into the second place. That means the whatever the whatever the words given in the words array, right? That is wrong. That is not in a lexicographical ordering. So that's why we are returning false. Hope that cleared up the logic. Basically, we will have to compare, or we will have to keep on going between the words till we encounter a letter which is not same, right? Obviously, if the first character itself is different, right, then we will sort or order based on that itself. So our task is to see whether the given set of words follow the alien dictionary's order or not, right? So for this, we will be going exactly the same order same logic that we saw in the case of example 2. So we keep on comparing the characters as long as they are not same. If they are same, we'll just skip and move to the next character, right? When you're comparing two words. So we are going to write an Eigen Pair for that by using the alien dictionary order. So that is the main gist of the algorithm that we are going to see. Okay, so let's go ahead and look at the code for this, right? So here we have the words, right? So what I'm doing is I am putting these words into a map. Okay, so to keep track of where those words were present, basically the index of those words, right? So I am putting that index into a map, right? So I and word of I, that is what it is going to be there in the map, nothing else. And after that, I am going to sort this words, whatever the words array, by using array.sort. For that, I am not going with a default sort. Okay, if we do with default sort, that will follow the English alphabet rules. But what we want to do is we want to use this order, right? Whatever the order given. So I created a new Eigen Pair and passing this order to that Eigen Pair. So I will be sorting based on this Eigen Pair, right? So now once the array is sorted, I am going to compare the order that I obtained after sorting with the order that was given with this for loop, right? So once you see if there is a change, right, you return false then and there. But if all of them are in the same order that are given, then you will return true, right? That means after sorting, if the order changes for any other words, you are going to return false. Otherwise, you are going to return true. Now let's go to what is the dictionary comparer is doing actually, right? So this is the main logic that is involved in. It is going to use this order, the string order. So let's go ahead and look at that first. So this is a simple Eigen Pair class which will take string and it is going to compare two strings, right? It is going to compare two strings. So we are passing the order to the dictCompare class, right? So based on that, it is going to store a map of the order. So map will have for each character what is its position basically. Since we have 26 characters in English and even in alien language also there are only 26 characters as per the description of the problem. So we will have 26 entries in the map along with their character and the position, right? That is what is given in the string order, right? Good. So now, so this is the Eigen Pair. Let's go ahead and look at the Eigen Pair. So we were passed with two strings for the Eigen Pair, right? So if at all, initialize the index of the for string A and string B as A index and B index, okay, and initialize them as 0. So if the character matches, let's say, right, if the first character match, then we will follow this logic. We will get to the logic in a minute. But if it doesn't follow, right, then what we are going to do is just compare those characters, right, and return that comparison so that it will be ordered in that. So how to get that character? We have already stored that map, right, in the map. So from the map, get the first character and get the second character, right? Even though I'm calling it as AIDX, BIDX, right? It is just 0, 0 anyway, right? So you get those characters order from the map and try to compare that order and return accordingly, right? So that way they will be sorted. For example, if the characters match in the example that we saw, the example 2 case, right? So W and W, it matches when you pass these two words for sorting, right? So it matches, then it will come here. So as long as A index is less than A length and B index is B length, and A, B, the corresponding characters match, right? We keep on incrementing. So we come out of this loop only when we encountered a character which is not a match. So we check again if AIDX is less than A length, BIDX is less than B length, and then get that particular character and compare those characters and return accordingly, whether first word, the string A should come first or string B should come first. Okay, that is what it being done here. For example, if one word is small and one word is big in the length, right? So then you might not hit that situation. So the word might exhaust, right? So for example, instead of word and world, right? If it was were and world, right? For example, right? So WOR and WORLD. So that means WOR is already exhausted when it is here, right? Then it will not enter this loop, this if condition. It will enter only this if condition, right? Else condition basically. So once if we see A index is greater than A length and B index is greater than or equal to B length, that means both of them are already exhausted. That means most likely both strings are same. In that case you return 0. Okay, that means they are equal. But if at all, if A exhausted, then you return -1. That means you should put A first, right? And if B exhausted, you put B first. So that is what it is. So this is what the sorting or the IComparer class that it is going to use when you sort the array of the words. Okay, good. Hope you understood the problem and the solution also. Let's go ahead and look at the time and space complexity for this, right? So the time complexity for this algorithm is, so since we are going through the word length one time, right, and next time, so there are 2 times that we are going through it, right? And so this is equal to the order of words length. That's what we could say, right? So this will be order of n. Let's say n is the length of the word, right? And this is also order of n, length of the where words dot length is n. But we are using the sorting here, right? So the best sort that we could think of is order of n log n. So the total runtime complexity for this will be, this algorithm will be order of n log n, right? So that's it. And then let's go ahead and look at the space complexity. So space complexity, we are using this dictionary, which is also equal to the length of the words. So that means order of n space that we need here, right, for this. And then let's go ahead and look at what dict comparer is using. So it is using this map again, right? So but this is a constant space because there are only 26 characters and 26 entries in the map. So you could take this as a constant space, right? So overall what you can say is order of n. So even though you have 2 placeholders, one is the integer and one is string, you could say order of 2n, but since we talk about big O notation as the worst case complexity, we will take it as order of n as the space complexity. So order of n log n is the time complexity, order of n is the space complexity. Hope that cleared up all your questions. If you still have any questions, please leave them in the comment section. I will get back to you as soon as I can. Just wanted to remind you again, if you haven't subscribed, please subscribe to my channel and share among your friends. Also, don't forget to click the bell icon. If you click the bell icon, you get all my future videos as notifications. Thanks for watching. I will be back with another video very soon. Till then, goodbye.